let's explore exponential growth and decay tables and graphs a little more. So here you can see I have the function f of x equals 2 times 3 to the x power. You can see the variable is in the exponent, making an exponential graph. In order to kind of see if we have a growth or decay going on, I'm going to test some numbers. My go-to numbers that I test for x with exponential is 0 and 1. And the reason why I choose 0 and 1 is because 0 and 1 are very easy to plug in and for me to use mental math to solve. I don't need a calculator. I can do everything quite quickly in my head. So let's go ahead and do that. So I'm going to plug in 0 for x. So I do 2 times 3 to the 0 power. Well, here's that thing that I can do mentally, because anything to the 0 power is 1. So 2 times 1 is 2. If I were going to plot that point, because I now have a coordinate, that point would be at 0, 2. Next, I'm going to take and plug in 1. So I have 2 times 3 to the first power. Again, anything to the first power is just the number itself, so that's easily computed. And I have 2 times 3, which is 6. If I go ahead and plot that point, 1 and then 6, 1, 2, 3, 4, 5, 6, I have these 2 points. Now, because you don't really know what to look for to know if this is a growth or decay exponential graph, I'm going to test one more number. And I'm going to test a negative so I can see what this graph is doing over here. So I'm going to go ahead and plug in -1 for x. So 2 times 3 to the -1 power. Now you should remember from your pre-algebra days that a negative exponent means you take the reciprocal of that number. So it'd be 2 times 1 over 3 to the first power. Oops, I don't really need the parentheses. Let me erase that. Just 1 over 3 to the first power. And of course, 3 to the first power, we calculated it there. It's just the number itself. So this would just be 1/3. So this is 2 times 1/3. I could put that as a fraction. And 2 times 1 is 2. 1 times 3 is 3. And that would be 2/3. So now when I go ahead and plot that point, it's at -1 2/3, which would be right about there. And now you can start to see how this graph is taking shape. So it looks like it's going to go this way and along like so. So this happens to be an exponential growth graph. It's going upwards when it reaches the positive numbers on the x-axis. One other thing I'd like to point out is it crosses the y-axis at 2. And by looking at this number right here, which according to the general equation, f of x equals ab to the x power, the a, in other words, excuse me, is what we call the initial value, meaning that's where it crosses the y-axis. So it crosses the y-axis at 0, 2, and yep, it does.